Let's begin with the fundamentals of LEDs and talk a little bit about how LEDs work. We first of all need to understand that LEDs are very different from any of the traditional light sources that we're commonly used to using. First of all, in an incandescent lamp, just to explain how these other sources work, a tungsten filament typically is illuminated by or heated by an electric current that flows through the filament until it gets hot enough that it glows, and then ultimately it emits light. One of the great problems, though, with incandescent is that it is extremely inefficient. In fact, only about 10% of the energy that we use to actually create this light is used for the lighting purpose, and 90% of the energy is actually used and emitted in the form of heat. Fluorescent lamps are more efficient, but nevertheless, the process by which they function is that we have an electric current or an electric arc that goes between two electrodes at the end of each of the tube. These electrodes ultimately, when the arc is created, excite mercury atoms that are inside of the tube, and ultimately these emit ultraviolet radiation. This ultraviolet radiation ultimately passes through the phosphor coating that's on the inside of the bulb, and this UV light is actually then converted to visible light. How do LEDs differ then? Well, first of all, LEDs stand for light emitting diodes. LEDs are very small light sources, and they become illuminated by a rather amazing process where electrons are actually passed through a solid material typically made out of silicon. And LEDs are in fact not much different than the semiconductors that actually operate our computers. How the LED actually produces light is that there are these elements called charge carriers, which are either electrons or electron holes. If you look at the diagram, you'll notice that the semiconductor, or the LED in this case, has what's called a p-n junction. That's positive on one side, negative on the other. And what the electrons do is that they pass through the semiconductor or the LED through the positive side, and when they get into the negative side, they actually jump into or fall into a negative element, a negative electron hole, which at that point actually emits light. So as complex as that may sound, which it is rather amazing and rather complicated, let's think of LEDs simply as very tiny light sources or light bulbs that can easily be fitted into an electric current. As we said, an LED starts with a tiny chip, most commonly about a square millimeter, and it is comprised of actually a series of layers of what we simply call semiconducting material. The LED packages then, because LEDs are so small, they come in groups of LEDs typically. They may contain just one chip, which is very seldom, or a group of chips mounted on a heat conducting material called a heat sink, and usually this entire package is then enclosed in a lens that helps promote and direct the light. The resulting device, that is the resulting single LED, is typically about 7 to 9 millimeters on each side and can be used separately, or this new word that we're going to have to be accustomed to, and that is an array of LEDs. Think of this as simply another term for a group of LEDs, but it's a term used very often now in the LED industry to define when you have a group of LEDs together. These LEDs, and then ultimately, much like with a computer, are mounted on a circuit board. Ultimately, this circuit board can be programmed so that the LED may be able to be dimmed. It may have other capabilities such as light sensing capabilities, and also potentially preset timing. And then this circuit board is mounted on another heat sink to manage the heat from all the LEDs in the array. So notice again, this term heat sink is coming up fairly often. That is because LEDs do emit light usually on the reverse side rather than in the direction that the light is being emitted. They emit heat backwards, and so this heat sink is a device, and we'll talk more about that when we get especially into the recessed lighting components. This entire package, that includes the LEDs, the arrays of LEDs, and then something that we'll call a driver and a light engine, are ultimately packaged together into an architectural structure, or even something that is very similar to our existing light bulbs. There are two main types of LEDs, and these are defined more by how they produce light. Low-powered LEDs are the ones that we've actually been using for perhaps decades. These are designed to draw attention to something. They don't emit much light, but they're used in things like exit signs, for example, the blue power button on a computer, or say the red blinking light on a video camera. And many times inside of our car, especially newer automobiles, most of the lighting inside of the car is actually created by LEDs. Our interest, though, primarily is in the high-powered LEDs, which are the LEDs that are used to illuminate an area or that are used in lighting fixtures to actually illuminate a space. There are today Energy Star qualified LED lighting that use a multiple illuminator inside of a fixture to produce white light. This is important because LEDs historically have not always been developed in a way that created white light in a very natural way. And we'll talk more about the issues related to LED color and how that's being addressed in terms of the new developments in fixtures.